my idea and all of my research is actually motivated by a simple question, which is, can we see through walls using wireless signals? So for example, if I take a handheld device and shine a wireless signal at the wall over there, can I start seeing on my screen how people are moving behind the wall and tracking their movements? What do you guys think? Is this possible? The answer is yes, to some extent. Today, we still cannot see the exact details of the face or the body of the person, or we can tell you exactly where the person is on the other side of the wall. So let me show you a video. This is the device that we built, and we put it behind the wall. So the device is in the other room. And we're going to use this device to track the person on the other side of the room, which is over here. Now, the output of the device is shown here in the bottom left corner, and the red dot shows us where the device thinks the person is. Let me play the video. So as you can see, as the person moves, the red dot is tracking him very, very accurately. And it does so even though he does not have any device on his body. And it turns out that not only can we track full body movement, as you can see here, but we can also track body part movements, like hand movements. So over here, he points at the lamp to turn it on. He points at it again to turn it off. It's a bit sad. He turns off the TV. And because wireless signals traverse walls, even if you leave a room and forget to turn off the light, all you need to do is this. And all of this is done using wireless signals and without requiring any device on the person's body. And this research has a large number of applications. So for example, some of the cool applications are in gaming. So you can imagine that you can play with the Xbox Kinect, except that you don't have to stay in front of it. You can run around in your entire home and it will still be able to track you. And it can also be used in gesture control, as I showed in the video. But it also has applications for first responders. Firefighters can use it to find where people are before they go in and risk their lives. And it can also be used in elderly monitoring. So how do these technologies work? At a very high level, we have a transmit antenna and a receive antenna. And what we're going to do is that we're going to take this wireless device, shine a wireless signal at the wall. So the wireless signal will traverse the wall, reach the person on the other side of the wall. Then it's going to reflect off his body, and it's going to come back. And what we do is that we design systems that generate these signals and capture their reflections. And we use these reflections to track the person's movements, as I showed you guys in the video. Now the natural question is, how small of a movement can we do that? So for example, in a room like this, where all of you guys are just sitting down and pretty static, can we track you? The answer is yes, because even when you are sitting still, you are breathing and your heart is beating. And we can sense these very minute movements using wireless signals. So for example, in this video, we put the device behind the camera, and as I play the video, you can see that the wireless signal is increasing and decreasing. And this actually corresponds to the inhale and exhale process. So if you try to zoom in on the chest, you might be able to see that change happening. And then when I hold my breath, this signal starts becoming sort of static. Why is it not perfectly a straight line? The reason is we are able to get the heartbeat. And this over here corresponds to the heartbeat modulation. Now, after a while, I will release my breath. So then you guys believe me, I'm going to repeat this video at 5 times the speed, and now I want you to really focus on the chest and see that we can actually see it in the video. And this is what we were able to capture using wireless signals. And once you can start sensing people's vital signs using wireless signals, it opens up a lot of new research directions. So for example, one of the applications that we were looking at is baby monitors. So we got a baby monitor, and this is the output video of a baby monitor. So this looks like a still image, but if you guys look over here, you will see that time is passing. But the baby is asleep, it's at night, and I had absolutely no idea whether the baby is alive or breathing or something. And then we got this, and we added the output of our device to it, and suddenly we are able to get the breathing motion, and we are also able to get the heartbeat in real time. So over here, the baby's heart rate is 127 beats per minute. And now we're trying to answer questions like, can we find the heart rate of a fetus with the mother's womb without touching her body? And can we get excitement levels or people's emotions by relying on these vital signs without putting any device on the person's body? So to wrap up, my journey at MIT started with an internship. I came here and I doubted myself. But grad school in general is an environment that harbors creativity. You have a lot of freedom in choosing what you want to work on, and there are amazing resources and amazing people that you could work with. There's, of course, a lot of ups and downs, but I do think that at the end of the day, it's definitely worthwhile. Thank you.